Hey everyone, this will be a quick video on how to evaluate limits of symbolic functions and just some of the properties of limits and their rules. Many of these rules are very intuitive. Like you're gonna go through this video and you may feel like, Schreiber, this is kind of dumb. Like, why? This seems like a no-duh kind of situation. And that's fine, and others, this may be really helpful just to kind of see this. But typically in calculus, we will refer to arbitrary functions, just like f of x and g of x, where they don't have a specific rule, but they still operate like a function. I have all of the notes here because I didn't want this to be an entire video of me writing stuff, so I'm just going to dive right into our definitions. So the first thing, the limit of a constant. So the limit of a constant function, and when we say a constant, we just mean like y equals 3. The limit of a constant function is always the constant, and that is because a constant function is a continuous horizontal line at that value. All right. Next up is the limit of a sum or difference, and the limit of a sum difference of functions is just the sum of those separate limits. So the sum of those separate limits. So if I have the limit of f of x plus or minus g of x, then that is the same thing as the limit of f of x plus the limit of g of x. Okay. Up next is the limit of a product. Works very much the same way. The limit of a product of functions is a product of the separate limits. So if I have the limit of f of x times g of x, then that gets me the limit of f of x times the limit of g of x. Okay. Up next, the limit of a quotient. Same thing. The limit of a quotient is a quotient of the separate limits. So f of x divided by g of x means f of x, g of x. Okay, so we can separate those two. Our last rule is the limit of a constant times a function. So in this case, k is representing a constant. And if we take the limit of a constant function, so if a function is being multiplied by a constant, the constant may be factored out, so we can kind of pull that out and becomes the constant times the limit of the function. Okay, so if I have k times f of x, then I can pull out this k and just evaluate the limit of f of x. Alright, so let's see how this works. So we're given some arbitrary functions, and this is what we mean by arbitrary functions. So like the limit of f of x is 5, or the limit of g of x as x approaches 2 is negative 2. As x approaches 2 of h of x, the limit is 1/2, and then k of x, the limit is 3. So these are just arbitrary values. So if we wanted to evaluate the limit of h of x, and I'm going to do this color-coded, h of x plus g of x, and that means I'm going to take the limit of h of x plus the limit of g of x. And we see from the given values, the limit of h of x is 1/2, and the limit of g of x is negative 2. And so that's going to become 1/2 minus 2, so 1/2 minus 4 over 2, or negative 3/2. And then our next one, if we have the limit of a constant times a function, so here is f of x, and I know I used red for k of x, but we could say like, okay, here is the constant that's being multiplied by it, and so what we can do is pull out that limit, or pull out that constant, and then take the limit of just f of x, and now we have 3 times 5, or 15. All right, so there are our limit properties.